Okay, so the question we're asking here is, what is the work energy theorem in Newtonian mechanics? So to explain, we're going to start off with a block on a level surface, and at some point that I've labeled x1 here, it's going to have a velocity v1, and at x2 it's going to have a velocity v2. Okay, so we have an object that's moved from one point to the other, and it has a velocity, different velocity at each point. So what we're going to say now is delta v, which is the change in velocity, obviously is just going to be v2 minus v1, and the displacement s is going to be x2 minus x1. So now if we go to our equations of motion, we can state, from one of the equations of motion that v2 squared is going to be equal to v1 squared plus 2as, where a is the acceleration. Or we can rewrite that as v2 squared minus v1 squared, by taking the v1 over to the left-hand side, is equal to 2as. Now, what we're going to do now is, and the reason for this will become evident in a minute, is we're going to multiply both sides of the equation on the right there, multiply both sides by m, which is the mass of the object. In this case, it's just a block on a surface. So when we do that on the left and right-hand sides, we end up with 1/2 m v2 squared, and the reason for it for the half is that I'm going to bring this 2 over to the left hand side and it becomes a half. So we get a 1/2 m v2 squared minus, sorry, that should be a minus sign, minus a 1/2 m v1 squared, and that's going to be equal to m times a times s on the right hand side. Now we can make another substitution here, because we know from Newton's second law that mass times acceleration we can replace with force. So ma is equal to F, or F equals ma. And now what we have on the right hand side is F times S. Now I've not put in my vector notation, my arrows on top of these quantities here, but it doesn't matter too much. But what we have here on the right hand side now is F times S. And F times S is the definition of work in one dimension here on the box. So F times S is the work done on the box. So what this is telling us now is this quantity, a 1/2 mv2 squared minus a 1/2 mv1 squared on the left, is equal to the work done on the box. So the work is then equivalent to the change in this quantity, a 1/2 mv squared. 1/2 mv squared. So we have a 1/2 mv2 squared minus a 1/2 mv1 squared, which represents, because the mass doesn't change, then this represents the change in this quantity, a 1/2 mv squared. And this quantity, a 1/2 mv squared, we'll call k, and that's equal to a 1/2 mv squared, and that's going to be the kinetic energy of the block. Kinetic energy of the block. So a 1/2 mv squared tells us the kinetic energy. And now what we've sort of proven with this is that W, the work done, is equal to delta K. So the work done, which we had over on the right hand side up here, and the change in the quantity, a 1/2 mv squared, is what we had on the left hand side up here. And we've proven that the work done on an object is equal to the change in its kinetic energy. So because the velocity has changed between v2 and v1, that means that the kinetic energy has changed, and that change in kinetic energy is equivalent to the work done on that object, and that's what we call the work energy theorem. Nothing to be too afraid of.